Morning and welcome again to the first online Congress of Natural Products Application, Health, Cosmetic and Food. We remind all the participants that the posters are still available online and distributed by areas, and with the possibility that you can download all the information in PDF format. Let's start the last speech section in the area of cosmetics. I remind all the participants who follow us on the YouTube channel that they will be able to leave their question in the channel chat during this section. The organization will select some questions that will be asked to the speakers at the end of the section. For a matter of time, and if it is not possible to explain all the questions, they will be sent particularly to the speakers to be answered later. I remember the speakers that this section is a continuous section of a short lecture lasting only 3 minutes each. To avoid delays in the program, please do not exceed the proposed time limit. The questions proposed by the channel participants, as I have already mentioned, will be exposed at the end of the 6th speech. So we will start. I move on to the speaker, Ana Costa, to start her pitch, please.
Can you hear me?
Yes.
Good morning to you all. My name is Ana Costa. I'm from University of Lisbon. And today my pitch presentation is about the development of formulation that convert garbage into glamour. And we are interested in assessing the organoleptic properties of formulation containing tomato extracts from residues. The aim of my project consists in collect tomato waste from a tomato Portuguese company. Then we use the green extraction methods to obtain lycopene enriched extract that are being incorporated into cosmetic products.
Sorry, Anna, you have a presentation?
Sorry?
You have a presentation?
Ah, I forgot to put.
You have to share the screen, please.
Yes, sorry. Are you seeing now?
Yes, we are.
Should I start from the beginning?
Yes.
Okay. My pitch presentation is about the conversion of development of products that convert garbage into glamour. And we are now assessing the organic properties of formulations containing lycopene enriched extracts from tomato residues. The aim of my project consists in collect tomato waste. Then we use green extraction methods to obtain a lycopene enriched extract that will be incorporated in cosmetic products. Here is a picture of 2 microemulsions with and without the tomato extract. The next step was to perform a sensorial analysis in order to know the opinion of consumers. And one of the aspects that we asked was about the odor intensity and odor perception. And for both formulations, the odor was classified as slightly perceptive and undefined odor. Then we ask about the probability of buying different care products with the odor of microemulsions, in particular a face cream, a body cream, and a shampoo. And we observed that the majority of volunteers prefer the formulations with the tomato extract. But when we ask about probability of buying the toothpaste with the odor of both microemulsion, the probability was really low. The next step was to ask about the color. And the color perception for both formulation was also classified as a pleasant color. Then we ask again the probability of buying care products with the color of these formulations. And we observe that the majority of volunteers prefer a face cream, a body cream, and a shampoo with the color of formulations without the extract. But when we informed volunteers that this formulation contained a tomato extract with antioxidant properties, we observed an increase in the number in the probability of buying these care products. Once again, the color of this formulation was not suitable for development of toothpaste even when we informed the volunteers about the probability, about the composition of the formulations. As a key point, to achieve a successful marketing product, we need to think about the type of the product, the composition of the final product, the source of bioactive agent, as well as the biological and pharmacological properties. And thank you all for your attention.
Thank you, Ana Costa. We will move on the next speaker, Ana Rita Silva.
Morning, everyone. Today I will be talking about part of my PhD work, and I will be presenting the work entitled The Optimization of a Tannin-Rich Extract using RSM. Cytinus hypocystis is a parasitic plant with a great potential to be applied in the cosmetic industry, since in our previous work, we correlate its high tannin content with its excellent cosmeceutical properties. Thus, the objective of this work was to optimize tannin concentration in the extract using heat and ultrasound-assisted extraction. We applied RSM to find the optimum combination between time, temperature or ultrasonic power, and solvent ratio to maximize the concentration of tannins in the final extract. RSM allows us to optimize processes using a small number of experimental runs. In this case, we applied a rotatable central composite design, which represents the 5 possible values for each one of the 3 independent variables. These natural values were converted to coded values that were later combined in these 20 experimental runs. We performed the runs in the lab and we obtained the final concentration of tannins for each method. A polynomial equation was fitted to the experimental values obtained in the lab and allowed us to access the linear, interactive, and quadratic effect of the independent variables on the final response. On the right, we have the polynomial equation for heat-assisted extraction, which allowed us to construct the following 3D representations. As we can observe, the solvent percentage, the linear effect of solvent percentage had the highest positive impact on the final response. As we can see in graph 2, independently of time, the tannin concentration was maximized when the solvent percentage was close to 100. Similarly, in graph 3, at lower temperatures, the response was maximized when the percentage was close to 100. Regarding ultrasound-assisted extraction, once again, the linear effect of solvent had the highest impact on the final response. As we can observe in graph 2 and 3, independent of time or ultrasonic power, we had the maximum response in solvent percentages close to 100. So considering all response variables, the optimum global conditions were predicted. Heat-assisted offered the highest concentration of tannins. However, ultrasound offers sustainable and economic advantages in time. Our next step will be to establish a correlation between the optimum conditions and their respective bioactivities. Thank you for your time and attention.
Thank you, Ana Rita, for your presentation. And now we will move on to the next speaker, Bruno Melgar Castaneda. You can start your presentation, Bruno.
Okay, thank you, Cristina. Okay, so good morning, everyone. My name is Bruno Melgar Castaneda, researcher from the Monta Research Center. And the topic I will be presenting today deals with the ultrasound extraction and time effect. Okay, I'm sorry for that. I would like to start by the end of optimization presentation, like the one we saw before, showing some two-dimensional graphs and stuff, and the terminology usually employed or encrypted code for others, terms like design of experiments, central composite design, or other now world famous response phase methodology. So if experiment design does not look familiar to you, just allow it a couple of months, because according to this data, from the web of knowledge using the RSM. The number of publications is growing rapidly, and great numbers in the biotechnology area like ours. If we look closer, we will also be able to identify some specific trend like the uses of optimization with ultrasound-assisted extraction coupled to response-based methodologies, and even more complex modeling and prediction approaches like artificial neural networks. But okay, before we continue, it's a good point to remember the basics. Usually for laboratorial experimentation, we gather some vegetative matrices, we sample prep, and then in this particular case, we use cavitation effect of ultrasound, which compress and expand the nucleated bubbles, which apply dissimilar pressure to the vegetative cell and result in the release of their inner bioactive compounds, the one we use for the natural applications. So from here, we could go back to the fancy and complicated terminology, or we could focus on easier graphs, but also meaningful data. For instance, in this work from our group, before we started the optimization process, we decided to focus on some important but yet overlooked information like the effect of time. While using ultrasound, we explore in 5 different species with very short ranges of time, from 10 seconds until 12 minutes. And although we found significant differences, we could not observe any specific trend like more time, more extraction. We have noticed some publication with very long times, like 52 minutes or 30 minutes. And even in my work in here, that is 2.5 minutes as an optimum point of extraction. But the important thing in here is not how many complex models we can use or hyper long or shorter times are better. The important thing is to keep asking ourselves, does my results make sense? Will 50 minutes ultrasound extraction properly optimize my bioactive extraction process? I mean, in optimization experiments, polarizing responses is not always the answer. We have to be aware of the future processes cost, not only from the economic point of view, but from the environmental one as well. So my personal suggestion is that academia has to be aware of industrial challenges and limitations and vice versa. But always as a scientist, we have to keep it real in order to make it work. So understanding, modeling, and processing data are magnificent tools, which should always be aligned with critical thinking and decision making. That's it. Thank you.
Thank you, Bruno Melgar. We now advance to the fourth pitch. We will move on to Diana Andrea Tavares Pinto. Diana, you can start, please.
Okay, thank you. Good morning. Can you see my presentation?
Yes, we can see.
So good morning, everyone. My name is Diana Pinto, and I'm a PhD student from Requinte Lacre Polytechnic of Porto. Today, I will present my recent work that focuses on the valorization of Castanha sativa shells as a potentially valuable raw material for cosmetic industry. So chestnut shells are an abundant and underexploited byproduct of chestnut processing industry, mostly reused as fuel and as a source of tannins in wine aging process. However, large amounts of this byproduct are still available. And for this reason, ongoing studies have focused on searching for novel applications, highlighting that these shells are excellent sources of bioactive compounds, particularly polyphenols and vitamin E, and reinforcing their potential of valorization as natural antioxidants. It is also worth to underline that the implementation of eco-friendly extraction processes embraces a huge challenge for industry. So the main aims of our study was to employ the ultrasound-assisted extraction to the recovery of polyphenols from chestnut shells and to provide a preliminary evaluation of their cosmetic potential. For this, the shells, after dried and ground, were submitted to an ultrasound-assisted extraction at 70 Celsius degrees for 40 minutes. and the aqueous extract obtained was further characterized regarding total phenolic content, antioxidant and anti-radical activities, skin cell viability, phenolic composition, and finally, ex vivo skin permeation using France diffusion cells. So the results revealed a high phenolic content and strong antioxidant and anti-radical properties based on the IC50 values ranging from 32 to 65 micrograms per milliliter of extract, and the highest radical scavenging efficiencies were obtained against nitric oxide radical and hypochlorous acid. Regarding the phenolic composition, the major phenolic compounds were ellagic acid, a caffeic acid derivative, and epigallocatechin. The results also proved that the keratinocytes and fibroblasts viability did not decrease significantly up to a concentration of 100 micrograms per milliliter of extract. In addition, the skin permeation study showed that ellagic acid and epicatechin were able to permeate the human skin after 8 hours, displaying higher levels of ellagic acid. In conclusion, these findings suggest that the chestnut shell extract obtained by ultrasound-assisted extraction have some efficacy and safety, pointing out a promising application in cosmetic fields. Finally, I would like to thank the national and international funds that supported this research, and thank you all for your attention.
Okay, thank you, Diana Pinto. It's time to move on to the next speaker, Maria Aurora Soares da Silva. Hello, Maria. You can start your presentation.
Olá, bom dia. Good morning. Thank you for the opportunity of presenting a part of my work concerning bioactive properties of 6 algae from the Iberic Peninsula Sea. Algae are known to be a good source of bioactive molecules described as having antioxidants, antimicrobial properties, among others, with a potential application in food, medicine, and cosmetics. In this work, the antioxidant profile, antimicrobial capacity, and neuroprotective properties were studied. The alga under study was Ascorphilium notosum, Bifurcaria bifurcata, Fucus spiralis, Imantalia elongata, Sargassum muticum, and Iondaria pinitifida. The extraction were made by microwave-assisted extraction in the optimized conditions described in this slide, and the microorganisms used to the antimicrobial tests are also presented here. Some experimental notes, we did the antioxidant profile. Antibiograms are made by plate diffusion method. All the extracts were brought to the concentration of 20 milligrams by milliliter, and we did enzymatic tests based in the Hellmann's method. The main results of the antioxidants and antibiogram tests are presented in this slide. It's notable that all algae species tested have effect against Staphylococcus aureus and none against the E. coli strain. In this slide, we can see the acetylcholinesterase and butyrylcholinesterase inhibition rates. Main conclusions. The most expressive antioxidant profile belongs to Ascorphilium nodosum. All algae extracts presented capacity to inhibit the Staphylococcus aureus growth, and the Bifurcaria crude extracts was able to inhibit all microorganisms tested except to E. coli. Bifurcaria bifurcata presents the best neuroprotective potential, being able to inhibit the butyrylcholinesterase action. Thank you for your attention.
Okay, thank you for your presentation, Maria Silva. I remind all the participants who follow us on the YouTube channel that continue to post their questions in the chat to be exposed to the speakers. So we advance to the last speech. We will move on to Patrycja Brudzyńska. Patrycja, you can start.
Okay, thank you. Is it okay now?
Yes, it's okay.
Okay, good morning. My name is Patrycja Brudzyńska, and my pitch presentation is about application of plant-derived colorants in cosmetic products. Nowadays, we observe a rebirth of the application of natural materials also in cosmetic industry. There is a strong need among consumers and companies to create such a cosmetics. There is a wide spectrum of plant-derived ingredients that are applied, but there's also a group of materials that is essential, particularly in color cosmetics. They are dyes. Nowadays, mainly synthetic or mineral dyes are used, but in the past, dyes were obtained mainly from different plants. But for some time, they got replaced by cheaper, easier to obtain, but not so beneficial for the environment and our health synthetic ones. But there is a huge selection of colorants in nature. There's a large number of fruits or vegetables that can be a source of color, like anthocyanins, carotenoids, betalains, or quinones. Thanks to the content of polyphenols and other biological substances, natural plant colorants can have other properties in cosmetics like antioxidant or antimicrobial, but their stability under the influence of light, high temperature, or pH may not be satisfactory in cosmetic application. Dyes are soluble in medium and can be used to dye cosmetic formulation, but to change the skin color, the pigments are needed. So to obtain plant-derived colorants that are insoluble and simultaneously to improve their stability, we've got different methods like obtaining polymeric dyes or laking natural dyes onto an inorganic substrate. And in the experimental part, materials that were used were plant extracts like strawberry extract, togberry, blackcurrant, black lilac, watermelon extracts, or cocoa and turmeric. And of course, inorganic substrate like talc and hydroxyapatite. Obtaining compounds were examined by skin coloring method to check whether they are able to color the skin and to what extent. To check their chemical structure, infrared spectroscopy was made. And to verify their stability under the influence of light, samples have been treated by UV radiation, and to check their stability under the influence of temperature, they were placed in the incubator. So the results, intensity and stability of color were varied because of different amount of absorbed colorants onto substrates and because of different content of coloring substances. But some of tested plant extracts can have a potential to be applied in cosmetics, but it still requires further research. But maybe they can be an alternative source of color in cosmetic industry. And thank you for the attention, and thank you, committee, for possibility to present.
Okay, thank you, Patrycja, for your presentation, and thanks to all the speakers for their interesting pitch. And now we will start the questions section for the participants who accompany us through the YouTube channel. Let me check if we have questions. The first question will be to Bruno Melgar, from Márcio Carocho. What do you propose to bring academy and industry closer?
Basically, what I was trying to show with the work is that sometimes we publish a lot of papers when we think that an optimized process is done, and we are considering like really long time of extraction, that when we do it, when we translate it to the industry, it won't be possible, or it won't be real, or it will be so expensive. So basically what I'm trying to say is we have to focus not only in the important methodologies that they have like really good look graphs, but we have to think further. How will this process will be implemented correctly, and if that is really going to work?
Okay, thank you, Bruno. The next question will be to Diana Pinto from Márcio Carocho too. Is it preview to be in the market anytime soon?
The extract, for now, not yet. But we are performing more assays about the efficacy and safety. We will perform assays using in vitro models, 3D models, like EpiSkin, to know about the skin irritability. And we will do a patch test to know the effects for in vivo application.
Okay, thank you, Diana. The next question will be able to Diana Pinto too, from Teresa Silva Brás. What was the skin model you used to perform the France diffusion cell assay?
We use I think the participant is asking about the skin model. I use a human skin recovered from abdominal surgery. That we have a protocol with a hospital, and a surgeon provides us this human skin recovered from surgeries.
Okay, thank you very much.
Thank you.
And the last question for Patrycja. It's a curiosity. For how long did the colorant last in the terms of shelf life?
Could you hold the question one more time, because I hadn't heard it.
For how long did the colorants last in terms of shelf life?
The shelf life is still in the experiment, so we are still making experiments. So now from this point, I can't answer this question because it's still in progress.
Okay, thank you, Patrycja, and thanks again to the speakers and also to the channel participants.